we're going to have Josh Day, who's going to show us how to do this in Julia. And so Dr. Josh Day works on technical scientific computing problems as a senior research scientist at Julia Hub, which was formerly Julia Computing. During his PhD in statistics at NC State, Josh discovered his niche at the intersection of statistics and computer science. He maintains many open source Julia projects, the most notable of which is OnlineStats.jl, a package for running statistical procedures on streaming and big data. Beyond software contributions, Josh also maintains the Julia for Data Science newsletter. So thank you, Josh, for joining us. Very excited to see Julia is another language that I am not familiar with. And I am also, well, I guess you did your degree at NC State, so North Carolina as well. So we're repping the ACC here, I guess.
Yeah. Awesome. Yeah, thanks for the introduction. You can all see and hear me and see my screen.
Yes, we can. Yep.
Okay, awesome. Let me bump the size up just a little bit. Um, yeah, so first thing I want to go over is just my very quick journey from R to Julia, which was my path. So yeah, I got a PhD in statistics from NC State. I was using R and RCPP to speed up some programs I was working on, and then my advisor, Dr. Huazhou, turned me on to Julia, and then I kind of haven't looked back. So the R and RCPP workflow is fine, but switching to just a single language like Julia and have everything be fast, and my lines of code was lower and stuff like that, and I found it a lot more easy to maintain. Um, and you'll hear a lot of other stuff about why I think Julia is great here. Um, So first thing I want to point out is I am using a Pluto notebook. So this is a Julia specific notebook environment that is more like observable. So that is like a JavaScript notebook. So the two kind of important things to note about Pluto is one is that it's reactive. So the state of the notebook is entirely decided on the code itself. So like in Jupyter, you have some hidden state about the order of cells that you run and stuff like that. In Pluto, it kind of automatically figures out the order that cells should be run in, and kind of constantly keeps it up to date. Um, the other important thing is that contrary to Jupyter, the output goes above a cell and not below. So here is a quick section of Markdown. And so here is my Markdown syntax, and you can see the output goes above it, and it gets, that Markdown goes straight into this HTML file and gets interpreted as HTML. Okay, so here in my quick setup cell, this is where I'm just loading all the packages that I'm using. One thing I want to point out is that the plotting library I'm using is called plots. One cool thing about that is that it kind of wraps a bunch of different back-end plotting. So here I'm using this function called plotly to enable like the interactive JavaScript plots as opposed to like static plots for a publication. So the plots that you'll see here are all going to be interactive. And then I have a couple of kind of small utility things for basically pre-printing some sections. Okay, but those are all the packages there. All right, so the first thing we'll do is load data. So just like Dr. Bates did, I'm using the CSV package, which is really fantastic. There's actually there's some great benchmarks comparing CSV to pandas and some of the R stuff as well. But here, let's open up our cell. So another thing that I'm doing is I'm hiding most of the code. So I've been using Pluto kind of exclusively for presentations like this for the last year or so, just because it's so easy to kind of, write and hide code and run things interactively. But anyways, okay, so here is the URL of our data set. I'm going to download that. I'm going to plug that into CSV read. I'm going to interpret that as a data frame. And I'm telling it what the date format is, saying I want to normalize names. So that's just removing spaces and making them underscores. And I also want to make sure that the string type is string. So CSV provides some more like memory optimized string formats, but we're going to ignore that for now and just use the base string type in Julia. All right, so I've loaded my data set and we get this thing printed out here. So this is the description. So printing out describe that data frame. So this is the same thing Dr. Bates looked at earlier. And it just tells us what our variables are, the mean, min, median, max, the number of missing values, and the element type. So yeah, so one thing you'll see in Julia, and it's kind of a quick check of whether a column contains missing data, is that the element type will be a union. Um, so for our date variable, so this was crash date, we can see that the element type is all dates, so we know that there's no missing values there. If an element type is a union with missing, so that's a strong indication that there could be missing values or that there's a possibility of missing values. Um, so that's just a good quick check there. Okay, going on to the first exercise. So the first thing was create a frequency table of the number of crashes by borough. And the data frames library itself has some kind of basic split, apply, combine functionality, which is a kind of a common um, a common procedure in like the tidyverse. And so the first thing we want to do is split. And so by this, we're gonna group our data set by borough. So to do that, I'm going to say group by my data frame by the borough variable. I'm then going to apply and combine these things together. So I'm going to apply this function called the number of rows. So I'm going to calculate the number of rows for each one of these groups. I'm going to want to call that variable count. And then I'm going to combine this all together back into a data frame. And so now I get my borough variable and I get the count of things there. And so here we also get our count of missing values. All right, so I am not actively monitoring the chat, but if there's any kind of live questions, I'm happy to kind of answer those as I go through this as well.
I'll chime in if we hear any.
Okay, excellent. Thank you. All right, so for the second exercise, we're asked to create an hour variable with integer values from 0 to 23 and plot those histogram of crashes by hour. So in Julia, there is a standard library called dates, and we are going to use that together. So from dates, there is this date time object. And so when we read our data frame, the crash date was read as a date, and our time isn't as a time object, it's just as a normal string. And so down here, I'm first going to create a variable called date time. And one thing I want to point out is that when a function name has this dot after it, so that is the syntax in Julia for broadcasting. So in comparison with like R, so say you call the sign function on a vector of numbers, it's going to automatically apply that function to every single number. Julia forces you to be a little bit more explicit for better or worse. So like the sign, there's no mathematical definition for sign of a vector. So in Julia, you would need to broadcast that function by doing sign dot over an array of numbers. So here I am pulling off the crash date variable from my data frame. Here I'm pulling off the time, and then there is a time object in the dates library. So I am broadcasting time over all of those strings to parse those into times. And then I'm combining those with all of my crash dates to parse those into dates and times. So one really cool thing about broadcasting in Julia is that these operations all get fused together. So if you're broadcasting, several functions all at once, there's no temporary vectors created. So if this function was just kind of like mapping over these values and creating a vector, then we would have basically a temporary vector here that we wouldn't be using. And so that would then need to get garbage collected because it's a temporary array and that hurts performance. So this broadcasting feature of Julia is really cool because you can fuse things together and really squeak out kind of every last bit of performance. And then there is an hour function that's provided by the dates library. And so here I'm making an hour variable, and I'm just broadcasting that hour function to pull off that integer of 0 to 23. And then I'm making a histogram of the hour variable. And I've done a few things to make the plot look prettier. And again, since I'm using that Plotly backend, we get this cool interactive JavaScript plot. Okay. On to the next thing. So exercise 3. So here we're checking if the number of persons killed is equal to the summation of the number of pedestrians, cyclists, and motorists killed. And so how we are going to check that here is, so here I'm actually going to use the map function. So here I'm creating nkilled, and I'm going to map the function of plus. So one kind of cool thing in Julia, another cool thing in Julia, is that infix operators are just like normal mathematical operations like plus and minus. Those are just standard functions. Um, so anywhere that you would provide a function as an argument to another function, so say to map, um, you can just provide those things like plus or minus or divide, and things will just work. So we have these three vectors here. So the number of pedestrians killed, number of cyclists killed, number of motorists killed. And so we're mapping this plus function over all of these three vectors. So it's going to do it's going to add each element together for each row and then spit out the result. And then here I am just doing a few calculations to get the percentage of the number of rows that have a matching sum. And then I'm spitting this out as a markdown result. So we can see that we're only missing one row that doesn't have a matching sum. As a small exercise, we can filter that thing out of which one is not that one. And we can see here we have the number of persons killed as 1. And wait, that actually does match, right? Is not equal to n killed. Well, I'm not going to debug this live, so I'm not sure what I did there. But I was trying to pick off the one row that didn't match. All right, on to the next exercise. Construct a cross table for the number of persons killed by contributing factors of vehicle 1. Collapse those things with less than a count of 100 to other. So here I am using this freak table function, and that comes from the freak tables package in Julia. All right, but the first thing that I'm doing is using from the stats-based library. It's called a count map. So let's just run that live real quick. And so what that does is that it takes all of the unique factors and then gives you the count of how many times that occurs. So the first thing we're doing is getting all of those, the counts of each unique item that shows up. We're then going to filter out the ones that have less than 100 as their count. So if I map a function over a dictionary, which is what count map returns, it maps it over the keys and values. So here I'm making sure that the value of that dictionary is less, or element in the dictionary is less than 100. And here I'm going to make just a small utility function that checks whether, so recode x, I'm going to check if x is in the keys of those small factors, and I'll call it other if it is, otherwise I'll just leave it there. And then I'm going to broadcast that little utility function over my contributing factor vehicle 1. And we're just calling that factor 1 here. All right, so then when I calculate that frequency table at the bottom, we get this result at the top here. So we have 17 factors, and we can see the n killed is 0 or 1. Okay. So one of the things that it asks us to do is check for association. Typically what people would do with a contingency table is a chi-square test. The typical like statistics textbook requirements or assumptions, they'll say that you want cell counts that are greater than 5 in order for the test statistic under the null to match a chi-square. And we don't have that. We have a lot of zeros and small counts. So a chi-square test isn't completely appropriate. But I do want to point out like where I'm getting this chi-square test from. So unlike R and more similar to Python, a lot of these things aren't directly built into base Julia. So in Julia, there is a hypothesis test package that I've already loaded, and inside of that package, there's this chi-square test. And if you throw in a matrix, which is what I've done here, it will automatically assume that that's a contingency table and go ahead and run that test. So if we had valid assumptions here, we would find, 0.0952 as our p-value. So we'd have, pretty weak evidence of any associations. All right. So our next task is to create a variable death, which is 1 if it's the number of persons killed is 1 or more. and 0 otherwise. So in this data set, there was only one, like the maximum of the number of persons killed is 1. So this death variable that we're asked to create is identical to n killed. But one thing that we can do, again, with Julia is broadcasting. So we're going to create our death variable, and we're just going to broadcast the greater than symbol of 0. So if the n killed is greater than 0, it'll be true. Otherwise, it'll be false. So we're changing this n killed variable to either true or falses, so zeros or ones. Um, and then so we're going to do another contingency table for, sorry, a cross table for death versus burrow. Because we have missing values in burrow, I'm making another variable called burrow2, which converts everything to strings, including those missing values. Just in case, missing is in like an important or a useful kind of indicator. Like maybe all those missing values belong to a burrow that was not included in the data set or something. So here we're including missing values. And again, we have the same issue as the previous chi-square test where we have a lot of low cell counts. But we could run that test again and get a pretty huge p-value. So no associations there if the assumptions were valid. So here, yeah, I wanted to show off kind of a quick side thing. So there's actually a small bug in hypothesis tests for this specific test. When it tries to calculate the confidence intervals, it ends up taking the square root of a negative number. I think it's because our assumptions are so violated here. But one way we can kind of cheat, or at least for like the data Jamboree is concerned, is to use R. So we can use this rcall package, which, if I'm remembering correctly, Dr. Bates is actually the original creator of rcall. And if I'm remembering the reason, I think it was because he had so much time invested in learning the lattice plotting environment in R that he wrote rcall so that he could still use all of his lattice commands in Julia. And so here there's a macro. So in Julia, a macro starts with the @ symbol. And the best way to think of that is as a function of an expression. Um, and so this rput says, take this variable called death versus burrow and move that into R. And so now inside of R, there is a variable called death versus burrow. Another feature in Julia is this idea of a string macro. So if I put a collection of numbers in front of a string, Julia can interpret that string in different ways. So if I use a capital R in front of this string, basically what it's saying is like send this string and evaluate it in R. And so here I'm using the chi-square.test function that is in base R on that thing. And it gives us the p-value, but thankfully this actually gives us a warning that the chi-square approximation may not be correct because of the low cell counts. Okay. So kind of because Julia was a latecomer to like the scientific computing world, interop with other languages is typically pretty easy. So similarly, there's a PyCall package, which makes calling Python really easily. Okay. All right, exercise 6. So visualize crashes using the lat and long and time, possibly with an animation. So first, here's a quick map of where our data is. And then I found some place to steal some GeoJSON of the burrow boundaries. And so here I am loading all that GeoJSON and turning that into a plot. And then here I am going to be plotting things after I've filtered the data set by hour. So one of the cool things that Pluto provides is kind of this interop between Julia and JavaScript. So Pluto provides this bind macro, which lets you bind a variable or like a JavaScript input to a Julia variable. And so here this clock thing makes it so that when I click start, this hour variable will start at 0 and then it'll every 2 seconds it'll go to 1, 2, 3, and just kind of keep growing. And because of the reactive nature of Pluto notebooks, when this hour variable changes, then this cell here, which references hour, is going to reevaluate. So let's go ahead and click start there. And so there's hour 0. Oh, there's hour 1, hour 2, Yeah, so this isn't like an actual animation. This is actually Julia reevaluating this plot every 2 seconds to plot the additional hour. And it's a little bit laggy, probably because I'm streaming this and whatnot. Um, but this interop with Pluto is pretty cool with JavaScript. Okay, and we'll just quit that for now. All right, for the next exercise, we're going to fit a logistic model with death as the outcome and covariates that are available in the data. Um, so I fit a quick model here, and the things that I want to point out are this formula macro. And so this comes from a Julia package called stats models, kind of similar to the Python one. And the syntax for creating formulas is more or less identical to the formula that's available in base R. So in this case, I'm only going to use factor one, which is the thing that we created earlier, and we added other as a variable or as a level. And there is death on the left side. And I'm also using the GLM package, so glm.jl, to call this GLM function. And I'm going to plug in this formula. I'm going to plug in this data frame, and I'm going to use a binomial model. So by default, this will use the canonical link, which is just a logistic regression here. One thing I want to point out is we didn't have many deaths in our data set. Yeah, so we had 17 deaths total, and we have 7,600 rows. So one thing I would say about interpreting the results here is that so we have in this like sparse scenario, so we have very few ones in our response variable and a lot of zeros. I would say interpreting the results of this are kind of sketchy. So I think going into sparse regression is beyond the scope of uh, of the data Jamboree, but I did want to point out that we probably should not be interpreting the results here too carefully. Okay. All right, on to the next exercise. So let's aggregate the data to the zip code level and connect with the census data at the zip code level. So here we have a data set that has the median income by zip code. There's some data transformations that we need to do. So some of the variables were strings that had some numbers in it, like the zip code had, I think, a couple numbers that prefixed all of the zip codes. So we got to get rid of those and then parse those into integers and move those as the zip code. And then similar with median income, some of the rows had commas and a plus symbol. So that was they had 250,000 plus as a level as opposed to a number. So we had to do some minor string processing and parsing those into integers. All right, so now we have our median income by zip code data. And separately, we have some shape files of the zip codes. So here I'm loading all of our different geometries, so all these polygons. So these are the shapes of the zip codes. And we're loading these things into their own data frame. So we have three data frames now. One is the crash data. One is the zip code by, one is the median income by zip code, and one is now polygons. So these shape file shapes by zip code. So now we're going to take those three data sets and move them all together or combine them together. So first we're going to do this, get the counts of crashes by zip code. So similar to that split apply combine that we did before, we're going to group by zip code. We're going to get the n row of each group, call that thing count, and combine those together. And then since we're going to plot these things later, I'm just going to drop all the missing values since we don't need those. We're then going to do a left join with the median income by zip code. We're doing a left join because we want to keep all of the, well, I won't go too much into the theory of left joins, but we're keeping all of the rows in the left table and joining them with the right table. And then lastly, we're going to do an outer join with all the shapefile geometries and drop missing values afterwards. So, and let's just do a quick plot here as a check. So here we're plotting the count of crashes by median income of the zip code. So just to see, so it looks like in poorer neighborhoods or poor zip codes, they tend to have higher crash counts than in the wealthier neighborhoods. Okay. So lastly, we're going to visualize and model the count of crashes at the zip code level. So I'm not doing any modeling here, but I am going to produce, so this is called a chloropleth map. So you're taking a geospatial area and you want to assign a numeric value to that, and you're going to map that numeric value to a color. So here we've taken our zip code geometries and we've plotted those things, and the color here is associated with the number of crashes. And so you can see as we get to the brighter yellow, it means more crashes. When it goes to the darker purple, that is fewer crashes. And we're plugging in these polygon objects, and those are just plotting the shapefile directly. And so that is just, yeah, so that's how we're plotting, well, geometries and assigning those things with colors. Okay. Well, so that is all the exercises. Do we
Thanks,
have some
Josh.
questions?
We do, and I know I said I was going to interject, and then I like you were doing such a good job. I didn't want to interrupt you. I like unmuted one time and then went right back. So maybe I'm not a very good moderator, but we did have we had one question in the middle, just about syntax. Chris was wondering if you could provide intuition for why the broadcasting period comes after the function names but before operators.
Oh, gotcha. Well, we can do a quick thing here too. So the plus function goes like this. Let's do. All right, we're gonna take two vectors, 1 and 2, 3 and 4. Um, so I think the reason is that this would be invalid syntax. Um, so the looking at this syntax here, if I wrote x plus dot y, um, that would be basically telling Julia that I'm trying to access the y property of the plus object, because usually you'd use a dot to pull off the property of something. Um, so I think the reason that plus dot then works is that now if you're this is basically the same, so that syntax of getting the property, but the property you're getting is like a function call. So I think the gist of it is that it has to, oh, that doesn't work. Oh, gotcha. I expected that to work. Anyways, so the gist of it is that it boils down to like what is allowable syntax based off of like what is already allowed syntax or defined syntax in Julia. So I think that was the way they solved it for infix operators. The dot comes before, and for function calls, it comes after.
It was, I was wondering too, because when I was looking, it looks like, so the dot, and this might be a really silly question, but it looks like it has two different purposes. It either is like if you're accessing, like it looked like when you accessed like a column within a data frame or like a feature within something, you could use the dot. But then also it was if you wanted to vectorize over or apply a function over.
Yeah, sorry. Yeah, that's a good point. So one of the ways I used the dot syntax was to rewrite the contents of something. So if I wrote so x is 1 and 2, and then I write x is dot equal to y, um, then this is going to do an in-place replacement of the elements of x. So if I run that, so x got replaced with the contents of y. So it's a way to basically like take the currently existing memory that x occupies and then just replace those values with the right side.
Awesome.
Hmm.
Cool.
Hmm.
I nice. All right, let me see. I think we have some other, let me scroll. Oh, oh no, there were just comments about the assumptions being so violated. You were creating literal imaginary numbers, so
Yeah.
that's exciting. Um, so when you this is also probably a silly question, but like a couple of times when you started chunks of code, you had like a begin and an end, and then there you have a let and an end. What are and
Oh
then
yeah. So
sometimes you don't have to have anything. Is there?
yeah. Because of the reactive nature of Pluto notebooks,
Okay,
it only lets like one block of code be allowed in a cell. So in order for like a block of code, so I can't write two things here.
I see. Yeah.
So because it's going to tell me either wants me to split this into two cells or to wrap it all on a begin and end. Um,
Okay.
so begin and end is just saying like just treat this as like I'm copying and pasting these two things in there.
Yeah.
A let block has its own scope. So z equals one. So this variable z isn't going to
This is going
exist
to exist
because
outside.
it's
Okay.
only inside of that scope. Yeah.
And is that so Pluto then, is this like, is Pluto, is that a Julia thing or a notebook thing or both?
Yeah. So it's a Julia specific thing,
Yeah.
and um, so I meant to post this as well. So this is the GitHub repo where all my materials are here. And if you click the notebook.jl, so this is the notebook that I'm running, and you can see that. So under the hood, it's just a Julia file, which is kind of cool. So you can just like include this as a normal Julia file, and it will run everything. Um, and then as I'm interactively doing things in the web browser here, like the Pluto package is rewriting this file under the hood.
Oh,
But so
nice.
unlike Jupyter, which has, like its own IPyNB format,
Mhm.
yeah, in Julia, it's just, or in Pluto, it's just a Julia file under the hood.
And so the fact that it's a Julia file, so are like the text portions of it just like comments in the Julia file, or how does?
Yeah, so I mentioned string markdown or
Oh,
string
got
macros
it.
before. So
Yeah.
if you're using the markdown module, that it provides this markdown string macro.
Oh,
And so
cool.
that's just markdown. Um, like there's also HTML objects, so we can write our own thing here. Um, and so
Nice.
so this is just saying like use the HTML text plain MIME type. And so
Yeah.
we can each actually like go into the source code and see that this is just
Oh, that's very cool.
let's inspect the element there. Yeah. So there is, yeah. We can see that this got wrapped in a div called Pluto output, and there's my hi that I just wrote there. Yeah.
Two questions from Daniel. The first is, are there features of Pluto notebooks that you prefer over Jupyter notebooks? And then second question is, have you tried Cordo yet?
Gotcha. So first, yeah, so the reactive nature of Pluto is kind of amazing, and it's still a little bit magical to me of how it automatically figures out the correct order to run cells. Like I haven't told Pluto anything about the order. And you can actually like you can reorder all of the cells in the browser, and Pluto will still maintain the correct order that they need to run. Um, so like
Do you mean like the order that you wrote them in or the actual correct order?
so say I wrote multiple definitions. Let's do A equals B plus one. All right, so here there's nothing called B, even though if I define B below it, uh, Pluto is reactive and automatically reacts to that change.
If you defined it be twice, is that
Yes,
what it was giving you the
yeah,
problem
yes.
with
So
before?
then it will complain. Yeah, there's
Got
another
it.
cell that already has B. Um,
Okay. So
and
you
then
would, but that would be how you would, like, if you did the like dot equal with B, then that would like change the original B or no?
yeah, so the because you can mutate things in Julia,
Yeah.
that is a little bit tricky with the reactive nature of things in Pluto. So as a general rule, you don't want to mutate things in Pluto.
Okay.
I am because I'm, adding columns to the data frame and things like that. Um, but if you ever get things out of sync, you can kind of like run the broken cell and then it will fix the order that things need to be run in. Um,
This is very cool.
yeah. And then so there's the reactive nature of things, and then just how you can bind variables to things to, let's say,
So
50.
like JavaScript, you mean, or
Yeah, so here, so basically this slider, there's a Pluto UI library. So this is called
yeah.
a slider. So this is like an HTML input.
Oh, yeah.
Um, and
And
now
then
we can
someone
do,
could actually use that.
yeah,
That's very cool.
yeah. All right. So the slider is bound to, let's do, there we go. All right. So there's zero things there. And now I can kind of change the slider and this plot should be reacting to it. What did I do? what is A here? So A is 18. This should be making 18 things. Oh, there we go. That's what we should do. There we go.
That is so cool.
Yeah. So now you can kind of just mutate this thing.
Can you use R and Python? Can R or Python run with, or is Pluto exclusive to? I guess other than you can use, it looks like you could run that R thing
Yeah,
that
so
you gave a little
you
bit.
would have to use rcall or
R
pycall.
call. Yeah.
Um, but yeah, so it's so specific to Julia because it's like it needs to figure out the order that cells are run in, and so
Mhm.
it needs to analyze like the actual expressions that you're putting in, and not just the output.
For that R call, sorry, I have so many questions. If anyone else has questions, please feel free to put them in the chat, and then we're going
Yeah,
to switch to let
yeah.
Sam do R. But one final question on the R call part. Um, it looked like you passed it as a string. Can you pass like multiple lines? I guess you could put semicolons or something, but is it?
Yeah, so you can also write strings like this.
Oh,
This
got
would
it.
be,
Yeah.
let's see. I don't think this is going to work because it's going to ask me. Oh, okay, it's an an issue. So no, if I already had set which cran mirror to use, like this would have installed ggplot 2. Um, and I might already have installed it in R. And oh, I do. Okay, sweet. And let's do that. And let's do.
Oh my gosh, that's so cool.
Oh, gotcha. Okay, so maybe it's not going to show up here.
It, but it's yeah, it's definitely running it, but it's not gonna.
And so, and let's call this thing Z, which doesn't exist. So the dollar sign is used to interpolate values into strings.
Okay.
So if I create a variable called Z, and then I can use that to like send that value from Julia into R. So this
Hmm.
is basically my understanding what Dr. Bates was using lattice, or how he was using lattice, when he was first getting used to Julia, is he made this R call library, and then he would just kind of interpolate his Julia variables into R and plot those with lattice.
This is very cool.
Yeah.
Okay.
So I think this works out of the box in Jupyter. I'm a little bit curious as to why it's not showing up here. But yeah.
Well, thank you, Josh. I want to switch over to Sam to make sure she's got time to do the
Sure.
full R part, and then we'll come back. If anyone else has any further questions for any of the speakers, make sure to put them in the chat, and I will try to ask them.
Okay, sure. I'll
Thank you
stop
for
sharing here.
showing this. I probably will have more questions after, so
Yeah, no, I'm happy to talk about it. Absolutely.
yeah,
Yeah.
so cool.
Mhm.